Lesson 8610, Finding Associations. Using data displays to find associations. In this lesson, you'll use relative frequencies in tables and segmented bar graphs to decide if there's an association between two variables. All right, we are on page 97 in your notebook. And I'm assuming that you've looked through the kind of grim lesson that was presented in Desmos about the sinking of the Titanic and ways to look at associations between different variables there. So in this lesson, we're going to use something called relative frequencies. Let's write this down, and I'm going to come back to that word and that phrase in just a moment. Use relative frequencies in tables and segmented bar graphs. You saw those in the lesson. And we're looking at those relative frequencies to decide if there's an association between two variables. We'll talk about what an association is in a moment. We talked about it with scatter plots, and it's going to be a little bit different as we look at it today. Okay, so let's go back to some of these words and make sense of another way that we can say these. First of all, using relative frequencies. In our last lesson, we looked at how frequently something happened. But when we talk about relative frequencies, we're going to be looking at percents. And that's going to help us to see whether there's associations. Speaking of associations, when I ask you if there's an association between two variables, what I'm really asking, or what you should ask yourself, is does the category that we're talking about make a difference? Does it matter? For example, when you looked at the Titanic information in the Desmos lesson, does it matter whether you're a man or a woman when it comes to survival on the Titanic? Does the category matter? Is there an association between you being a man or woman and your survival? So we're going to be coming back to the percents and whether the category matters as we look through a couple of examples of data. Now I'm going to start with these two relative frequency tables. And again, when I say relative frequency, I'm talking percents. These look a lot like the two-way tables that you saw before, but this time instead of just raw numbers, you're given a percent. And that's going to help us to see associations. So we're going to be looking at this data that's about flu treatment results. There's people who got treatment A and people who got treatment B. Is there an association between which treatment that you had and whether you had any improved health? Now, as I'm looking through this data, the people who got treatment A, 57% of them had improved health, where people with treatment B, only about 41.7% had improved health. And that's a pretty significant difference. So when I ask myself in a moment, does it matter which treatment you get? I'm going to say yes. If I had the flu, it sure matters to me. I want to have a much better chance of improved health. So let's come over here and fill in some information. Blank of people who took treatment A had improved health. Treatment A, improved health, 57.5%. So that's treatment A. Whereas blank of those who took treatment B had improved health. Treatment B, improved health, 41.7%. So looking at those percents helps me to determine whether there is or is not an association. Because those percents are so different, and this is close to 60 and this is close to 40, I'm going to say there is an association between treatment and improved health. Going back to my question from up here, when I'm asking, is there an association? I'm asking, does the category even matter for the outcome? And in this case, I'm going to say absolutely. The category of treatment A or treatment B does matter. Treatment A gives better results. So I'm going to say the treatment that you were given matters for your health. If it matters, if there's a difference, then we'll say there is an association. I'm going to skip down here to this relative frequency table and go through the same process about determining whether I think there's an association. Let's scooch up just a little bit. Let's just explore this real quick and understand what this relative frequency table means. When I say relative frequency, I mean we have percents there instead of just raw numbers. And this is about wearing lucky socks and winning. So here's all the people who wore their lucky socks and what happened, and all the people that wore regular socks and what happened. And we're seeing, does it matter when you wear your socks whether you win or lose? Or does it influence whether you win or lose? Well, let's look. The people who wore their lucky socks were winners 80% of the time. And the people that wore their regular socks were winners 79% of the time. Now, those are pretty close percentages. That seems to indicate there's not a lot of difference whether you wear your lucky socks or your regular socks when it comes to winning. You could wear either sock and you'll be just about equally likely to win. I don't think we need to worry too much or be too superstitious about wearing socks. So let's think this through and what association means again. In this case, there is not an association between wearing lucky socks and winning. And the reason for that is the category doesn't matter. I'm going to say I'm equally likely to win regardless of what socks I wear. And I know that 79 and 80 aren't equal, but there's so little difference. I'm equally likely to win regardless of the socks I'm wearing. So there's no association between winning and wearing lucky socks. Coming back to here, there is an association between your treatment and whether you get improved health. That's a pretty big difference. But 80% and 79% is not a real big difference. Let's look at a segmented bar graph and ask the same kinds of questions. Let's get to know our bar graph first. We have cell phone ownership. Remember that segmented bar graphs are always going to be the same height because they're always going to come up to 100%. I think they should have put percents on here. And the two categories are kids and adults. Let's look at the key over here to understand what the shaded and non-shaded regions are. The non-shaded region means these people have a phone, so under 25% of kids own a phone. And the shaded region are the percentage of kids who don't own a phone. So it looks like over 75% of kids don't own a phone. So regarding owning a phone, does it matter whether you're a kid or an adult? Heck yeah. Look at the difference in these percentages. For kids, the likelihood of them owning a phone is under 25%. For adults, the likelihood of them owning a phone is over 75%, almost, pretty close to 100. So because there's such a difference, I'm going to say there is an association between age and cell phone ownership. So I'm asking, does the category matter? Yes. The percentage of kids without phones is much greater than the percentage of parents without phones. And that's what you're looking for, a difference in those percentages. I could say the percentage of kids with phones and compare that, but I figure you'd be more focused on the number that don't have phones. The percentage of kids without cell phones, that's the shaded part, is much greater than the percentage for adults. So if this was all about associations today, I'm going to return to this same question. When you're asked, is there an association between in the data, you're being asked, does the category that you're looking at matter for the outcomes? And using percents is probably the easiest way to figure that. So how can you tell when there's a possible association between variables? Well, a possible association exists when there's a big percentage difference. All this hinges on percentages. Between how the total is split between groups. That total 100% is split between groups. All right, so there's a lot of new thinking to do here. We used relative frequencies, which was changing the raw data into percents, to decide if there was an association between variables. Really asking, does the category we're looking at even matter? If the category really does matter, there's an association.